Hello, 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 hello. I am live. Good morning. Good morning. Good morning. Is there anybody out there? Good morning, good morning, good morning. Okay, maybe one viewer. Hey, Leanna. Good morning. I think you're the only one in here right now. Now, maybe not. Okay, so the link should be operational. If you can, please check the board, make sure that it is working. I'm going to just check a couple of things here before we begin. Give everyone a minute or so. Sombrero, that's right. Good morning, Cynthia. How are you? So the board is operational. I hope you have your sombreros on today. It is Cinco de Mayo. And a little bit different Cinco de Mayo, given everything that's happening, but it's still festive and hope, yes, Feliz Cinco de Mayo to all. I hope that it's going to be a festive day. Try to make it as festive as possible. I mean, I think people are starting to go out more. Um, it's kind of tough just to stay inside all day and, not appreciate a beautiful day. So, again, just exercise caution when you go outside. But it's really hard to stay indoors these days. But I hope that you're all able to get some type of Mexican cuisine today. Heck, even Tostitos, right? Tostitos and salsa. If you can't make it to a Mexican place, Mexican fast food place, Tostitos and salsa will do the trick, I think. All right, so we'll wait for a few more minutes. So with regards to the homework, it is due today, but I extended the time only because I wasn't able to submit the actual questions that I wanted you to answer until a little bit late yesterday, so I didn't want to penalize anyone for that. So I extended the due time today till basically midnight, so you have some time with that. So we'll wait a few more minutes, and then we will begin. Good morning, Sarah. Good morning. So the board is operational. We have a few people in. And yeah, we'll begin in maybe like a minute or so. I really don't want to take up too much more of your time. So I submitted your grade, so I can talk about that. So whenever you get report cards, I'm guessing it's going to be on a Thursday since that's what was done traditionally. So whatever's on Jupiter now, that should be your grade approximately. So that's accurate right now. So you can refer to that. All right, so let's not waste too much time and let's get right to it. So, with regards to what we were talking about yesterday, so we were looking at the coordinate plane and we were looking at essentially finding the lengths of a side of a right triangle if we had a coordinate. right? So we're trying to figure out not only the lengths of the side of a right triangle, typically I think we're looking for the hypotenuse, but we're also trying to figure out the value of trigonometric functions. So we looked at the 6 of them, sine, cosine, tangent, and the cofunctions, cosecant, secant, and cotangent. But what we're going to look at today are the ranges now of these functions. So typically we do look at domains. Domains, again, it depends on the type of function that we have. So the domains can be limited. The ranges could also be, it depends. So we're going to look at these examples here just to look at what's happening. So if we look here at the range, so we have trigonometric functions. We're looking at sine theta and cosine theta. So if we look here, the range. So here we're looking at, so this is what's called set builder notation. So that we don't typically look at. I mean, we can use it. So let me just look at this a little bit closer. So our focus today is going to be on essentially the range of using interval notation. So again, set builder notation, it is used, but it's not really the focus of our conversation, but I think we're used to interval notation, so we'll be focusing on that. They essentially mean the same thing. So if we look here, the range, according to what we're looking at here, sine theta, cosine theta, we have a range of -1 to 1. Tan theta, cotangent theta, we have a range of -infinity to +infinity. And then for secant and cosecant theta, it's a little bit different. And this comes to life when you actually look at the graph and you try to plot this. So if you look, and you can do this, you can go on Desmos. It's just a little bit more difficult for me to share. But if you type in, so here's x and y. If you type in sine theta, or sine of x into Desmos, I'm now on the whiteboard. Sine theta should start at the origin, and you're going to see it's going to wave like this. It's going to have this cyclical wave. So again, this is very poorly drawn, but the reason why we're talking about the range specifically is because that's really the area of interest here. So if we're looking here, again, this is so poor, I'm so sorry. So if we're looking here, so it peaks. The range has a peak. So if we're looking here at sine theta, it's going to peak within the range, so along the y-axis. So for sine theta and cosine theta, that's going to be -1 and 1. And if you look at tan theta, that's a little bit more complex when it's plotted. One second here. Okay. So if we look, so you should be doing this now, and I want you to go to Desmos and just type in tan theta. I mean, you can use your graphing calculator. I'm just having a bit of a tech issue, sorry. So tan of x, it's quite interesting. So if you compare it to the range, right, of what's given for sine theta and cosine theta, the graph looks kind of bizarre. So that's number one. So it looks something like this. So it starts at the origin, but then you have something that appears this way. So it's kind of, wave-like in nature, for sure, but the curves are interesting. They're unique. But if you look at this, and we're focusing on the range is infinite. The domain is a little trickier, right? Because there's just certain spots that it's going to intersect across the x-axis, right? That's number one. But it's also asymptotic, as you can see, along certain values of x. So it gets a little bit tricky. And then again, that goes with the undefined nature of tangent. So if you remember from our discussions yesterday, when we looked at tan theta when it was at 90 degrees. We can go back to that. I think that was the quadrantal angle. So here, hold on. Right. So sorry, I'm just looking back here. Right, so if you look at tangent, so it's undefined at certain angles. So that it happens at 90 degrees, it happens at 270 degrees, so every 180 degrees, or you can think of it as every pi, it'll become undefined. So if it's undefined, it's going to be asymptotic at those values. So that's why the graph looks a little bit odd. And again, just to reiterate what we spoke about yesterday also, the signs or the functions have different signs, whether you're in quadrant 1, 2, 3, or 4. And that was discussed with our little acronym that we mentioned yesterday. All students take calculus. And we're going to explore that today when we look here at our first example. So when we look at sine theta, so what we want to figure out, first of all, right? When we actually evaluate these angles, so if you're to put sine 90, you know the value for that already. You can put sine 30, you could put in sine 60. All of these have values. So if you take a moment, I think we said yesterday that sine 90 was what? 1, right? And you can look at it this way. And this is kind of a sneak peek as to where we're going with this. So if you recall, sorry, that's 30 degrees, 60 degrees, and 90. So if you remember some things about 30, 60, 90, there's a rule for side lengths. And that rule relates to having specific ratios. And we're just touching upon this right now on a superficial level, so that this way we have an argument that we can make. So if you do the sine of 30, and I hope some of you did, you'll see that's the same as 1/2 of 0.5. And if you look here, sine of 60, it should be radical 3. But if you take the square root of 3, I believe that's going to be about, what, 0.7? Roughly, rounding. Or 0.8, excuse me. So, the question that we're looking at now, if you open up the handout, let me just see here. Let's go to our handout. If we go to the class stream, so the handout, let's look. It may still be the same one that we were working on. It is not. Okay. So the first example, I know there's a lot of handouts here. Right, so it should say trigonometric functions and Pythagorean identities. So we're on this handout now. So again, it should say at the top right, trigonometric functions and Pythagorean identities. So the first example should look like this, sine theta. So why I reviewed sine 90, sine 30, sine 60, because you're going to get a value. So now the question is there a value for sine theta that will equal to 2.5? So what we're trying to figure out is whether that's possible or not. So some logic, right? So think about what sine is. So you have to think about the ratio itself. Sine theta is opposite divided by hypotenuse. So something to consider. The hypotenuse is always larger. and then the opposite side will always be smaller. So if that's the relationship, sine theta cannot be greater than 1. So now the question is this, is sine theta then equal to 2.5? Is that possible? So hopefully logically you're thinking no. So it's not possible. So now you have to start almost predicting, right? So if you're actually given a value for any of these trigonometric functions, you have to think to yourself, is this possible? But on the flip side, if we were looking at secant theta, right? So that's something that we need to consider also, right? So if we're looking at, cosecant theta. So if we're looking here, right, because this is the same as 1 divided by sine theta, then the question is cosecant theta of 2.5, is that possible? And then the answer would be yes, because if you're flipping the opposite divided by hypotenuse, and that becomes hypotenuse over opposite side, then that can be greater than 1. So then this is a reality, whereas for sine theta it is not. So let's look at the next example. So the next example is tan theta. So if we look here, tan theta, and we have what? 110 and 4700. So the question is this possible? So some things to consider, right? Because tan theta, it's opposite. So here, divided by, adjacent. And here we have the hypotenuse. So something to think about, right? Does it matter whether the opposite side is larger or smaller than the adjacent side? Here it doesn't really matter because the hypotenuse must be the largest side. So in this case, tan theta, it's definitely possible. So this is okay. That can work. And then lastly here, if we look at secant theta, don't forget what secant theta, or how you can rewrite it. Right? So, secant theta, if we think about it, is the same as 1 divided by cosine theta. So if we're looking at this, and remember what cosine is, right? Cosine is adjacent divided by hypotenuse. So I'm having you think now kind of outside the box to some degree, right? Because the adjacent side has to be smaller than the hypotenuse. So this cannot be, or it must be less than 1. Has to be. Right? So if that's the case, then on the flip side, if we're looking at secant theta, it's going to be hypotenuse over the adjacent side. But then conversely, it has to be greater than 1. So if that's the case, then it's just not possible. So this is basically what we're looking at, or a summary of what we just discussed. So potential values for sine, tan, secant theta, or essentially these 6 trigonometric functions. So again, just exploring the relationships, predicting certain values, and understanding the relationships of the side lengths in a right triangle. Good morning, Edgar. There's 12 of you here now. All right. So let's keep moving along then. So here we have the following. So in this second example, so it says here, suppose that angle theta is in quadrant 2. So we're looking at the board, right? So here's quadrant 1, 2, 3, and 4. So we're here. So now the angle is in quadrant 2, and sine theta is equal to 2/3. Now it's saying to find the values of the other 5 trigonometric functions. So something to consider. So the terminal side we can say is in quadrant 2. Right? We're here. And apparently here, if we look, we can create a right triangle. So here's theta. Right? Although we're looking at this angle here, we can look at the difference from this entire 180-degree relationship, right? Because if we look here, I'm going to make this arc here. So this is all 180 degrees, right? So the red arc is a portion of that 180 degrees, but the remainder would be theta. So I can use this angle here to then build my right triangle. So we can consider that almost, or what's called, a reference angle. So I'm just going to redraw that so that we're just focused now. So again, just redrawing. We have our terminal side, and we should label, because what we know is this. Okay, here's theta, and apparently sine theta is equal to 3, I'm sorry, I think it's 2/3. So what we need to do then, if this is theta, then this becomes opposite divided by the hypotenuse here. So our opposite side length is potentially a side length of 2. The hypotenuse then is potentially a side length of 3. So when we're looking here, we don't know what that is. So we're going to call that x. And it is because again, we could use x and y because we're on the coordinate plane, but this refers to x because it's this horizontal distance. So we need to find that value. So again, since we have a right triangle, we should apply Pythagorean theorem, and I'm going to give you a moment to find that. So take a moment to do that. I'll give you 1 minute. So as you locate that value for x, I'm going to see what Mexican dishes we like. I love reading your comments, by the way. I do look at them. They do not go unnoticed, that's for sure. Hopefully you don't make me too hungry. So again, about a minute to solve for that value of x. Chicken tacos, enchiladas, tacos de carnitas. Ooh, carnitas are so good. Let's see, tamale. Wow, quesadillas. Yes, steak quesadilla. Chicken mole. Wow, that's nice. Tamales, chicken quesadilla, chicken fajitas. Everyone here is making me hungry. Chicken fajitas. That's some good stuff. So I guess we're the only ones. Where's that? Valentina. We're the only ones that like fajitas? No joke. I was in California. Where was I in California? Palm Springs. So I go into a restaurant, and there was some person there, and they ordered fajitas, but they pronounced it fajitas. And I was really confused. I'm like, what are fajitas? I've never heard of fajitas. And I'm like, wow, this sounds pretty interesting. And then it came to me. But it's okay. The waitress knew what that person wanted. That's all that mattered. Anyway, so hopefully you found x. Anyone? I got square root of 5. Thank you, Kyle, for participating. So you got tired of my fajita talk, and that's okay. So 3 squared equals to 2 squared plus x squared. So in doing that, we should have 4 plus x squared equals to 9, x squared equals to 5, and we clearly have x is equal to radical 5. So good. So with that information now, so I'm going to redraw this triangle. So we have this theta. So hopefully you're following along. I've been told that I don't need to draw arrows anymore, so we're good. So now with respect to this angle, right, you should get into the habit of labeling the sides as opposite hypotenuse and adjacent. And just a note of caution, when you set up these ratios, if you have a radical in the denominator, it must be rationalized. So we can get away with sine theta. That was given to us. So we're in good shape with sine theta. I believe we're also in good shape with cosine theta. And if we look here, we have radical 5 over 3. Danger, though, when we look at the reciprocal or the cofunction. We're in danger there. We're in danger also with tan theta. We have tan theta, then it's 2 divided by radical 5. No good. We have to simplify that. Although cotangent, we're in good shape because then it's just a reciprocal. So there we're good, but we need to remedy cosine theta, or the cofunction of that. We need to remedy tan theta. So hopefully you did that, and I don't want to waste too much time, but in doing that, I'll do one of them. I'll do tan theta, so that this way, at the very least, if you just need a quick refresh. So tan theta will have to equal to 2 divided by radical 5, but we are rationalizing that denominator. So we're left with then 2 radical 5 divided by 5. And when we look at the rest of them, let's see. We should have this. But hopefully you looked at the following. And I hope that you noticed something here. And something that we need to pay attention to, right? Because we are in quadrant 2. Right? And the only thing, right, and something to think about. Although, yes, we have radical 5, it's really negative radical 5. Something for you to consider. Because that is the x component. So if you look here, we did find x, so I'll rewrite what we found x to be. Right, we're here. Right, we created our right triangle, but this value here is really negative 5, comma 2. So although, yes, you solve for x, right, x is radical 5, but we have the option of having it plus or minus radical 5. In this case, we're going to make it negative radical 5 because we are in quadrant 2. So we have negative radical 5, this is 2, this is 3, but the location of that point is negative 5, or negative radical 5, excuse me, 2. So then, following the rules, right? All students take calculus. All students take calculus. The only thing that should be positive is sine. So when we review sine, so sine theta was 2/3. That's good. But then cosecant theta, reciprocal, 3/2. Cosine theta, we had to be careful, right? So that's actually going to be negative radical 5. Divided by 3. I believe that's what it was. Right. And we're okay with that. Right? Because again, the radical is in the numerator. Tangent. We corrected that, right? We said 2 radical 5 over 5. However, since it is in quadrant 2, it is negative. Cotangent theta then. Right? We did the reciprocal of the original, but here that would be negative radical 5 over 2. And if we look at the reciprocal for secant theta, which is now shown, you should be looking at that and rationalizing that denominator. Then it becomes 3 radical 5 divided by 5, but not positive, it's going to be negative. So negative 3 radical 5 divided by 5. And again, do not forget to rationalize the denominator. And again, I think we mentioned that cotangent theta was negative radical 5 divided by 2. So things that you have to pay attention to. The sign, right? What quadrant you're in. what functions are positive, what functions are negative. So what I want us to do, I want us to answer, because we need to do this one again. So I want to do 2b. So we're going to answer 2b. I want to give you about 5 minutes to do that. This is something that normally I would say, just do this on your own, or, let's rush. Not rush, but let's move on to the next part. But I really need you to practice this because this gets a little bit confusing. So we're going to look at 2b. That you're going to do with me, or you're going to take some time to do that on your end, and I'll definitely review it. But here, just things to consider. We're in quadrant. You know what? For our argument, we're going to change 2b. Actually, no. You know what? Let's see here. You know what? Let's do this. Let's do 2b. We're going to do that, but we're going to be in quadrant 3 because the solutions that I have for you that I'm going to show you are for quadrant 1. But that's too easy. You know what? How about this? Do 2b as is, and then I'm going to have a follow-up question to that. So answer 2b. So 2b, answer that. And again, here theta is in quadrant 1. So you force the right triangle. But the extension question is going to be this. How do the signs change in quadrant 3? And I'm going to abbreviate quadrant 3 with Q. So you're going to answer 2b. Right? I have it set up for you. It's on the whiteboard. So the extension question to that is, how do the signs change in quadrant 3? So I'm going to give you about 5 minutes, because this is a little tougher. Don't mind the noise. So again, I need you to practice this one. Again, like I said before, normally I would just give you the solutions here, but with this type of question, you have to get used to the drawing, to the placement of where the sides belong, but then also the actual value of the functions, whether they're positive or negative. So again, this is for sine theta. So I want you to do 2b. A few more minutes for that. And if you have any questions, please just ask away in the stream that we have on the side, or the side chat, excuse me. Please ask away. Just so you know, that demonic sound that you heard in the back is my Keurig machine. I know, very exciting. If that sound even came across. So as you do this, I'm going to start working on it also. So this way you have a guide if you want to make sure that you're doing it correctly. Right, so sine theta, remember, opposite divided by hypotenuse. So if we have that, we clearly have to solve for the missing side. So here in this case, that's the adjacent side. Sorry. So hopefully this is something that you're getting. Don't forget the plus or minus. And don't forget to simplify, right? Simplest radical form. So hopefully we're on the same page here with that missing side length. And then I'll just put it back into the triangle. Here we have our theta. So again, the adjacent side, 2 radical 11. And again, things to consider. You are in quadrant 1, so we're looking at this value from a positive lens. You have radical 5, and you have 7. So now we can start setting up all of the ratios here. So sine theta, I believe we were given. Cosine theta we can do as well. So if we do that, then we have 2 radical 11 divided by 7. And then tan theta, which is where we will run into a problem. So the problem is that we have to, again, rationalize the denominator. But we'll do that shortly. I want to make sure that we at least have everything written out in the ratio form, and we'll worry about rationalizing the denominator shortly. So cosecant theta, we have secant theta, I'm sorry if my handwriting's a little sloppy today. So at the very least, so if you zoom out, you should get a good idea, or you can see the whole picture. So you have all of the values for the 6 trigonometric functions. All right, obviously you're given sine theta, but then the rest of them, cosine theta, tan theta, cosecant theta, secant theta, and cotangent theta. So again, if these terms kind of confuse you, they're just fancy ratios. And the ratios with the cofunctions are just reciprocals. So the challenges that you're going to have is, I think in this case, it might be rationalizing the denominator. That might be one of the challenges that you face. So again, if you look here at the solutions, I have presented them for you. So I gave everything for that try on your own section. So everything is there. So you have your sine theta, which that's what we started with. Cosine, everything I gave you, but now the only difference here is this. So what's different, if you look at tan theta, it's been rationalized in the solution. So when we have radical, radical 55 divided by 22, so what I'm going to circle now, I'm circling now in red, this function has been simplified, or rationalized, I should say. Similarly, cotangent, so these two that I'm circling here, that's also been rationalized. So that's why if you just look at the denominator quickly, right, we started with 5, now it's, or radical 5, excuse me. So when you multiply radical 5 with radical 5, it becomes 5. Similarly, when you multiply 2 radical 11 with 2 radical 11, it just becomes 22. Well, excuse me, not 22. We're not multiplying both by 2 radical 11. I take that back, excuse me. Just radical 11. That's why it's 22. My apologies. I didn't mean to confuse you. And then similarly, the same approach is taken for secant and cosecant. Any questions so far before we move along? Actually, it's going to be very tough for us to move along because the next part is somewhat complicated. And I can't really rush. So this is like one of the issues with this unit. There's a lot of substance, there's a lot of meat here, and if I rush through it, it's to no one's advantage. You know, I think I've said this in the past, you know, if I rush through something and you get nothing out of it, then what, we save time but in vain, because then I'll have to reinvest that time later anyway. So with these particular sections, I'm going to try to take my time, because the next section is a little more challenging, but I'm hoping that at the very least what we covered today reinforced what we did yesterday, right? And what did we do? We looked at the 6 trigonometric functions, we looked at the values, right, or the signs of those trigonometric functions, whether they're in quadrant 1, 2, 3, or 4. Here, what we were given is just the ratio, right? So what we focused on today was having a trigonometric ratio given to us, right? So like 2/3 or radical 5 divided by 7. And that forced us to place it on the coordinate plane and to get an idea as to where we needed to, first of all, put it on the coordinate plane in terms of quadrant, the missing side, whether it was x or y, and then also the side length. So here are the signs of these trigonometric functions. So in this case, I asked you, how would the signs change if we were in quadrant 3? So remember, we're in quadrant 1, all of these are positive. In quadrant 3, all students take. So 10 is the only one that's positive. So what I circled here, tangent, right? In quadrant 3, those are positive. Tangent and cotangent. The others are negative. So that's how that would change. So if you go with the mindset that you're in quadrant 1, so that this way you're dealing with just positives, and then you change it later on to the appropriate quadrant, then you'll be fine. So if that's, a strategy that you want to use, then take it, right? Because what we did here was we solved in quadrant 1, and then we looked in detail. But what if we were in quadrant 3? So then we have to identify which functions are in fact positive and which are negative. And I think that's all for today. Any questions? Any questions? All right, so what I'm going to do, I'm going to try to post the final exam review sheet. So that's going to be my goal for today, because the final exam is coming. Again, I'm not really too sure what the date is yet, and it would be good for you to start practicing some of the older topics. So there will be homework tonight that will be due for Friday, but you do have homework that's due today by, I think I have it for midnight, and that was basically what was assigned yesterday. So if you finished it, great. If you did not, you have until midnight to do that. The homework that will be for tonight, so I can just give you a heads up, go to the classwork, trigonometric functions, let's see. Yes, so the handout that's entitled Trigonometric Functions and Identities, Homework Day 1, I want you to complete that. So again, so if you can find it, it's entitled Trigonometric Functions and Identities, Homework Day 1. So whatever I have circled, you should be able to do. So it starts with 3, then 7, 10, 11, and then 27, 28, 31, 32, and you'll know which one it is because I'm going to edit it now, and I'm going to have it due for Friday. So this way you know. And then that will appear on our classroom stream. So it's saved. It should be in the stream now. If you look, yes, upcoming, due Friday. And then you click it, and it shows up. So now this is, super simple, less confusion, and I think you can do that easily. I will upload the review sheet, I'm hoping again by sometime today, and you should start looking at that. And as always, as we get closer to the final exam, we'll try to narrow down some topics so that that could become the focus of your studies, and hopefully everyone is well prepared for when that exam is. And again, I don't have an exact date, by the end of the month, and that's all for now. That's all I can share. Any other questions for me? Comments, concerns? If not, then that's it. I'll wait another 10-15 seconds, and then I'll let you be so that you can enjoy your fajitas. All right, so on that note, have a great day. Happy Cinco de Mayo. Try to be festive as best as you can. Eat as much Mexican food as you can. And I will see you on Friday. Hasta luego.